Good afternoon, ladies and gentlemen of Precalculus. Yesterday we worked through in this quick review exercise set problems 1 through 4, which had to do with polynomial division. And now the next part of the set is 5 through 10, factor the polynomial into linear factors. And what we say linear factor, what is the meaning of the linear factor? I think we've talked about this recently in class, haven't we?
Yeah, we did.
I forgot what it, anybody remember what a linear factor is? Elizabeth, do you remember what it is? Karina, do you remember what a linear factor is? Yeah, so Karina's talking pretty softly, but if you had something like x plus 5, that would be an example of a linear factor. Also x, 2x minus 3, that would be a linear factor. What do all these linear factors have in common? X and x to the power of 1. Okay, x to the power of 1 is what makes these factors linear. For instance, we look at this one, x cubed minus 4x. What kind of a polynomial do we call this one? What kind of polynomial do we call this one? X cubed minus 4x. Pull out your vocabulary. What do we call that thing? What do we call this thing here? This would be a linear binomial, linear monomial, linear binomial. What is this called?
Binomial?
It is a binomial, but what kind of binomial?
What's nonlinear? The opposite?
It's called a cubic binomial. Okay, we talked about quadratic trinomials, right? This is a cubic binomial. And so how do we go ahead and find the linear factors of this? So Elizabeth says factor out x. So we have x times what times x equals x cubed. So we got squared and minus 4. And any other factors to be had? Any other factors to be had? What is x squared minus 4 factored?
X plus 2, x minus 2.
Okay. What are the factors of this?
X plus 2 minus 2.
Yeah, so x plus 2, x minus 2. So this would be our answer here. Okay. Questions on that? Okay, good. Let's go on to the next one. We have this one here. I know what we need to do. I need to go out. I need to get the name wheel on this guy. And I know we're missing people today for purposes of. So somebody help me factor number 6. Oh, this name wheel here. So Robert, you are the man. Robert is the man. Here we go, Robert. What do we got here?
Factor 6.
So he says 6 comes out here. So we have left x squared. What goes out here?
Minus 9.
Minus 9. Okay, and next.
X plus 3, x minus 3.
Any additions or suggestions to that? Okay. All right, very good. Good job, Robert. I'm trying to remember what these look like here. Okay, yeah, here's another one that we have. And what do we call this kind of thing right here? A what?
Trinomial.
A trinomial? What kind of trinomial?
Linear.
Quadratic trinomial. Why not linear? Why quadratic?
Because it doesn't need a line with graph.
Oh, okay. Elizabeth is going over the top on this one. He says, because it doesn't make a line when you graph the thing. Because it's true, if you graph this thing as a function and set this like f of x equals this, you would not have a line. You would have a curve, right? And that is what I was thinking. So she gave a better answer than I would have given. But it's because it says is squared, the highest is squared. And where do we get the word quadratic from?
Four.
No?
Quadrant.
Quadro, right? And it comes from the Latin word quadrado. Quadrado. And what does the Latin word quadrado mean?
Square.
It means square, exactly. And that's where in Spanish, okay, so in French. So let's go ahead and choose somebody to help us out with this. So Robert, we have removed your name from this. Appreciate that. And we're going to have, in this case, Karina's going to help us out with this one. Karina, all right, Karina, you can help us. What do you get for this, Karina? So she says factor the 4 out here. And so that's going to be 4x squared, then what? Plus 2x minus, what do you say, 15? Karina talking behind the mask. And so what do we have for this one?
X minus 3 and x plus 5.
So she says quantity x minus 3 and x plus 5. So that's minus 3x plus 5x. Does that look good? Yeah, it looks real good. Okay? Good work, Karina. So we're going to go on to number 8. And so number 8, I am going to spin the wheel on that baby again for the next person. And I say this one here has a little bit of added complexity to it. So we're going to see who gets this one. It's going to be Elizabeth or Justin. We'll see how it goes. It's Chloe. So Chloe is not here to defend herself. I'm not gonna remove her because she could show up. So let's go ahead. Spin. It's gonna be Elizabeth. All right, Elizabeth, you're on the spot. Yes, Elizabeth. Okay, what do you think, Elizabeth? She says factor out x. Okay. Then, what goes in here? 15.
15x squared minus 22x plus 8x.
Okay. Is that as far as you got? As far as Elizabeth got. Okay. Well, this is one of those ones that's a more complex factoring because first of all we just don't have 1x squared, so I'm going to go like this, and I'm not 100% sure how factorable this thing is, but what's going to go up here? AC, right? Well, what's going to be 8 times 15? 120? And then b is going to go down here, which is negative 22. So can we think of factors of 120 that are 22 apart?
Negative 10, negative 12.
So 10 and 6,
No, negative 10, negative 12.
10 and 12?
Negative.
Okay, negative 10 and negative 12, she says. Does that make sense? Yeah, you add them, right? Add up to negative 22, multiply. So now we divide by 15. So we have on the right, is that negative 4/5? That's what that is, right? And this one here on the left, that's, is that negative 2/3, something like that?
Yeah.
So what we have here is x minus 2/3, x minus 4/5. So we can now do our bottoms up things. So we got 3x minus 2 and 5x minus 4. Is that right? And then we just kind of multiply them back together, see if we get negative 22. Yeah, we do, right? All right, thank you, Elizabeth and Karina. Appreciate you weighing in there. Are you okay on this, Elizabeth? Yeah. Did you try to use the X method there and did you try to use a box method and work backwards? Well, here, the thing about this is harder to use with a box method because between 15 and 8, there are just a lot of different possibilities. And the more possibilities you have, the more guess and check you have to do if you don't use the X method. I never used this X method in my factoring career before I got into teaching, and I was just fine. So, all right, good job. Okay, now we come into a different level of factoring here because you have these cubics, and they're just, do you see any way to make sense of this? Well, there are ways. Yeah. So what it is, there's more complexity in this one, and ironically, what we're going to be doing subsequently in chapter 2.4 is going to address how possibly to factor such a thing. But one thing you can do is do something called factoring by grouping. And what you do is you can take this x cubed plus 2x squared, and you go ahead and take that as a group, and then you take this negative x minus 2 as a group. And then what you do is factor out what you can out of this. Well, here you have a negative sign, so I'm going to have, and here you have x squared. So you have x squared times x plus 2, right? And here you have a negative sign times x plus 2. What do you notice here? Do you notice a common factor between these two? Yes, you do. So what you have is the common factor is this x plus 2. So you have x plus 2 times x squared, and then you have this 1 left over, x squared minus 1. And now can you factor out this x squared minus 1? Yes. So you have x plus 2, x minus 1, x plus 1. So that would be number 9 done with the factoring by grouping. Has anybody ever seen factoring by grouping before? It can help sometimes. We're actually going to examine another technique in the chapter. But let's go to number 10. So let's try to do number 10 similarly to the way I worked out number 9. See if you can make some headway with that. Did you notice a pattern here on this one? Anyone? It's like you're too busily immersed. Justin, you got this one? Justin's shaking his head no. Robert, did you get it? Good. Elizabeth, did you get this one?
No, I'm
Almost done, she said. Did you get this one, Karina?
I'm working on it.
He's working on it.
Yeah, I got stuck. Did I get stuck?
So you got stuck on this? Are you ready for me to start talking about this one? Elizabeth, are you ready for me to start talking about this one? Karina? So what we do is we're going to try the same thing we did last time by separating this into 2 groups. And then over here, we're going to have minus 9x squared minus 9x. And we're going to factor out our common factor. And what's our common factor going to be here?
X cubed.
Yeah, x cubed. So you have x cubed, and then we have x plus 1, right? And over here, we're going to have, what's our common factor here?
9.
Well, yeah, 9, but what else? Negative 9x. So we have negative 9x times x, what?
Plus 1.
Plus 1. So do we see a common factor in these two?
1.
Yes, we do. This x plus 1, right? So here's our x plus 1. And we multiply that by x cubed minus 9x. And now can we continue with our factoring? Yes. So what is our common factor of this thing here?
X.
X. So we have x plus 1, and we factor out x, we have x squared minus 9. So what do we end up with on this thing? X plus 1, and then x plus 3, x minus 3. Okay, so that's it. Okay. What we're going to do is start into chapter 2.4 today. legitimately. And let me erase that. We're going to talk about polynomial division. So here, I can get your papers later here. Go to artistry. Yes. So you can change that here, it doesn't. I'll show you. And I will trade you on this side. Is that fair trade? Well, we're going to deal with it. Okay. What we have here, an exercises, oh, that's not the one I wanted. This is the one I wanted. Divide each polynomial as indicated. So we're going to introduce something called, we're going to introduce two things, and in Algebra 2 Honors, we did talk about these last year. What were the methods of division we talked about last year for something like this? Do you remember them? I'm really leaning on Elizabeth and Karina at this point. You remember what we called it? You remember what we called this to divide something like this? What method did we use? You remember that?
I know the method that.
You know the method, but you forgot the name of it? Well, the two things we've talked about last year, we talked about a polynomial long division. And we're going to do that probably with this problem. And we talked about another type of division, starts with S. So who remembered that? Justin. Justin, good job, Justin. Synthetic division. And as a matter of experience, just my experience as a teacher over the years has shown me amply that synthetic division, if you can do it, is going to be, for most people, easier way to go. So anyway, we're going to divide this thing out. Now, what do we have to do? I'm going to set this up as a long division problem. So what goes in here?
2x squared.
Okay, 2x squared
Plus 3
plus 3 plus 5x. And then outside goes x plus 1. Okay, is this correctly designed? It is? Okay, if I'm taking 273 and dividing that by 3, would that be exactly the same as taking 723 and dividing that by 3? Are these the same thing?
No, that's moving 5x pretty good.
Yeah, and so Justin picked up on my analogy.
Oh, yeah.
See, Justin noticed it. Okay, thank you, Justin. Very good. Okay, Justin caught that. And so what it is, you have to worry about place order in this, is the point I'm trying to make here. And so now we divide, what is 2x squared divided by x?
2x.
So we got 2x here, and 2x times x is 2x squared. And if you do it right, this first, you're going to have the same term here in the first thing. And then what is 2x times 1? 2x. And so now what we're going to do is subtract, and sometimes it's easier to see if you just make parentheses here and subtract. And what's 2x squared minus 2x squared? 0. And what is 5x minus 2x? 3x. And then we bring down this 3. So what is 3x divided by x? That's going to be 3. And 3 times x is 3x. And 3 times 1 is 3. So what do we have left over here? We have nothing, 0. So we call these, the different parts of these things are, this x plus 1 is called the divisor. What is this thing here, this 2x squared plus 5x plus 3, what do we call that?
Dividend?
Okay, Karina said, and Elizabeth said dividend. Did you say that, ladies? Yes. And then what do we call this thing right here? Is that Justin? Is that you, Justin? Quotient, yes, quotient, very good. Yeah, the quotient. And what do we call this thing right here? Okay, Elizabeth, the remainder. All right, very good. So just some vocabulary, and we're going to go over these problems. If you look at the problems on the back, that's where the exercise set started, but I added these 8 to kind of help us get along. And what I want to do on the next one right here, number 2, is I want to demonstrate synthetic division on this one. And so we'll do this one with synthetic division. And to do that, we're going to rewrite this one as x squared plus 3x minus 15. And we're going to divide that by x plus 3. Now, what you find for this is x, the number you're looking for is the 0 that is involved here. So if we take x plus 3 and set that equal to 0, what is x equal to? -3. Yeah, x is equal to -3. So that's going to be a key value in our synthetic division. And then there are different ways of doing this. I like to just make a synthetic division bracket like this and place the value of the 0, which we got from here, on the outside. On the inside, in order, we press 1x and 1x squared, 3x, and minus 15. And then we bring down the 1, and so we have 1, and this is what's called the x squared place. And next we have 3, -3 times 1, so we get -3, and 3 minus 3, they cancel out, we get 0, and -3 times 0 is 0, and finally -15 plus 0 is minus 15. So that's actually, I actually lied to you. That is not the x squared place, that's the x place. That looks better now. And this will be the numbers place, just the constant, we'll call it the constant place. And this one right here, that's our remainder. So our answer for this is going to be x, that's our quotient, plus 0, so we don't put anything, then minus 15 over x plus 3. So this would be like a summary statement for the problem. Okay? And then going back to number 1, if we were to do the same thing on number 1, we would have like 2, 5, 3. We put the -1 out here, so you get 2, -1 times 2, this is going to be -2, 3, and -3, 0. So we get 2x plus 3, okay, which is the same thing we did by long division. All right? What I want you to do now is look at problem 3, and I want to get our random name generator for help with the number 3. So are you working on number 3 right now? Now I know we did this in Algebra 2 Honors last year a fair amount. Did you do this last year too, Justin? Sounds like you did.
Yeah.
You remember doing this, Robert, last year? No? Were you right next door last year?
Yeah.
Okay. Yeah. We did this. We spent a good piece of time on this. Algebra 2 Honors last year. What I'm going to do before, I'm going to blow up the wheel here, but Justin, did you do number 3 yet?
No.
You're working on it still?
No.
Okay. So I want you to help us out with number 3 because you're the only other one class here today. Are you using synthetic division on this one?
I was doing it for the first one to see if I knew.
Did you know how to do this one?
That's a lot of money.
That's a longer one. What about you? Did you do this one? Did you do this, Robert? Give me another. Let's see what you Looks like Karina is doing long division.
Yeah, I'm doing long division too.
Yeah. And what's happened is long division is a helpful skill to still retain, because if you happen to have anything other than a single x, it makes synthetic division more complicated.
We have to do long division for construction, just for like a daily thing.
For construction?
Yeah, it's in Mr. Celeste's class, construction.
So he has you do long division?
Yeah,
Okay.
he gave us a whole bunch of problems, and that's when I noticed I forgot how to do a lot of middle school things. I was like,
Yeah,
what?
yeah. Yeah, that's the thing about mathematical skills a little bit. They can sort of go fallow on you.
I forgot how to divide fractions and multiply and stuff.
So here, yeah, we got x cubed minus x squared plus x and plus 8. Is that right? And then, did you do this yet, Justin?
I'm trying.
He's trying. Okay. All right, I want Justin to help me with it. That's what I'm angling on. Putting Justin on odds. Okay. x, actually this would be x squared. Because you have x squared, and then that's going to be 0x plus 1. That's x squared plus 1 plus that. So you got the remainder making up. So x squared plus 1. So Justin basically got it right, and so I'm gonna just kind of show what he did. And really, the only place he got stuck was at the very end, was in the final interpretation. But, so I'm just gonna recreate what Justin had down here. He put -1 out here, and then 1, -1, 1, 8. Was that what you got, Justin?
Doesn't the 1 go up there? All on the left is.
Oh, it's gonna be +1, you said. Okay, there. Yeah, Justin corrected that. Thank you, Justin. And so we bring this down here. Now here's where you can have, if you're dividing x cubed by x, this is going to be your x squared place. And so to me it's important to get that first one, because if you get off on the right foot, well then you'll be okay. And then we have 1 times 1 is 1. -1 plus 1 is 0. And this is going to be in our x place. And then we have 1 times 0, 0. 1 plus 0, 1. Okay, this is our constant place. Constant, just a number, right? And then we have 1 times 1, 1, and 9, and what is this called? This is our remainder. Let's abbreviate remainder. So our summary statement is going to be x squared plus a 0, so I'm just going to ignore that and not put anything there, plus 1 plus our remainder over x minus 1.
Do you do it in a long form?
Pardon me?
Do you do a long division?
You want to do a long division too? Okay. Yeah, and Karina did this long division wise.
Yeah, but I think I got stuck.
You got stuck on it, so we'll work it out long. You did it, you got it long, you got the same thing long division,
Yeah,
right?
thank you.
I didn't know I was stuck.
You want to take pictures?
Yes, and then they told us to stay and eat lunch.
Yeah, that's what Chloe came in and told us. So let's go ahead and do that too. If we take, I'm going to go write this out as x cubed
Minus x squared.
minus x squared plus x
Plus 8.
plus 8. And we put x minus 1. And we divide out, we're going to get x squared, right?
Yeah.
And x squared times x is x cubed. And then x squared times
1.
-1,
Negative x squared.
negative x squared. So if we subtract these out, we get
0.
0. And then we're going to bring down the x, right? And
You don't
what's,
bring down the 0? I mean the 8?
you could leave it and bring it down later, but we'll just bring it down because you said so. Let's do that, that's fine. But we could drop it down later, right? Well, that's still good. So what's x divided by x?
1.
1. So we have plus 1. Remember we had 0 in the other one. So 1 times x is x. And then 1 times -1 is
Negative 1.
-1. And if we subtract out, what's 8 minus -1?
7.
It's 9. So we get x squared plus 1 plus 9 over our divisor, and so we get the same thing, right? Okay. We probably have time to have one more. Justin, I appreciate you working with us on that. That was really awesome work. And what I'm going to do is I'm going to blow up the wheel and call somebody randomly for number 4. So here it is. We're going to open 6th period again. No, we're open fifth period. Got my periods wrong. Here we go. Now I know we're catching Riley flat-footed on this. We're catching you flat-footed, aren't we? Did you do any of these division last year? Oh,
Yes.
okay.
But I need to,
So you're not totally flat-footed, but as far as being in class today, yeah. So we'll give Riley a pass or have somebody help Riley if she gets called. No, we got Karina again. So Karina, did you do this in long division? Is that how you did this
I
one?
don't know the
She did all these in long division. So what I'm going to do, do you remember Riley doing synthetic division last year?
I don't know the term, but if I saw it, maybe.
It's the one with the bracket. I'll do this one both ways. I'll do it Karina's way first. So Karina, let me see. Can I just see your paper here? I'm just going to copy Karina's paper. Okay. So we got number 4. So she got 2x up here, right? And 2x times x is 2x squared. And 2x times -3 is -6x. And then if we subtract out everything here, we're going to get -5x minus -6x, which is,
And we have 1x.
that's actually going to be positive 1x. Think about it, right?
Oh, yeah.
-5 plus -6. And then we can bring down this -3, and x divided by x is 1. 1 times x, 1 times -3. What is our remainder? 0. So our answer to this division is going to be 2x plus 1. And in synthetic division, you would do it this way. You put 2, -5, -3, and 3 goes out here. So we're going to have 2, 6, 1, 3, 0. So we're still going to get 2x plus 1. Okay, did you remember any of that last year? Okay, so pretty simple. And we're just going to leave it there. I'll put a star on Karina's paper, and we're going to resume on this tomorrow probably, actually. We'll have just a decent class period. And did I give you a star on your paper here, Justin?
What?
Star on your paper.